Welcome students. We will be understanding linkage and recombination through Thomas Morgan's experiment. It is a very famous experiment on Drosophila melanogaster, and we know the reasons why Morgan chose Drosophila for all his experiments. That has been discussed in the previous videos. And it is a dihybrid cross because here we are going to consider a pair of traits, that is two traits we are going to observe and their position. Then we'll be understanding what is meant by linkage and recombination. Now here are two different crosses. A female was chosen which has having yellow bodied and white eyed. So the female had yellow body and white eyes, whereas the male was having brown body and red eyed. So here we have put a symbol. Yellow body is marked as Y and white eyed is small w, that is in a lowercase. Brown body is marked with a superscript plus sign Y again, and W red-eyed is marked with the W plus. Plus is superscript. This is also the wild variety. In the cross B, we have taken a female which is white-eyed and with miniature wings, and we have used the symbols W and M both in the lowercase for the respective traits. The male is a red-eyed and normal wing. So red-eyed is marked, or we have used the symbol W and plus sign is superscript. M over here is again superscript with plus sign. This is also wild type. Now let us observe what happens over here. When these two were crossed with the traits, it was found that the F2 progeny resulted into the parental type with 98.7%, whereas the recombinant type with only 1.3%. When he performed the cross for another trait, over here, he observed that the F2 progeny showed here the parental type of 62.8% and the recombinant type with 37.2%. Now you can make out that over here, the parental type of F2 generation and the recombinant type, the percentage varies greatly in both these two crosses. Now, what can be the possible reason? And with the help of the test cross, they were able to justify, they were able to analyze about the position of the genes. Now, as you can see over here, a graphical representation is made over here. You can see the distance between the genes coding for yellow body and white-eyed trait. They are placed very close to each other. Over here, these two genes are placed very close to each other. And when we talk of cross B, the two genes which are corresponding for white-eyed trait and miniature wings, the distance is more. Over here, the distance is comparatively less. Now, since the distance between the two genes is less over here, this type of cross, that is the cross A, will not allow crossing over and will not show recombination much. The percentage of recombination will be low. Percentage will be low. These genes are said to be linked genes because these two genes are inherited together in the cross A. these two genes show more linkage as they will not allow the crossing over, thereby reducing the frequency of recombination, and as a result we do not see much variation and the recombinant type is only 1.3%. When we come to cross B, you can see over here the distance between the two genes is more, and as a result it will allow crossing over. So in this case it allows crossing over, but sometimes and not always. Secondly, it permits recombination to a certain extent. It is recombination and crossing over are all possible because of the distance between the two genes. Are not inherited. So these two genes are not inherited together always. And whereas in this case, they will be inherited together. So by performing the test cross, it was confirmed that the position of the genes matter a lot, whether they will be inherited consecutively in successive generations. And in this type we find in the cross A type, the parental type will be more because of more linkage and less recombination, and the recombinant type will be less. That means it will not allow variation. Whereas in cross B, there will be more variation of genes because of the exchange of the genetic material, and the recombinant types are more, that is 37.2%. So I hope you are able to understand the experiment, which gives us a better idea of linkage and recombination and the position of the genes which play an important role in this phenomenon.